Welcome to this presentation and this YouTube channel. My name is Piri Kamban. All right. You can reach me on 0978 56 58 76. Then you can also reach my colleague Taomba Mbondo through 0979 67 3809. You can WhatsApp us on those lines. Now, let's get back to the main essence of this video. So in this video presentation, we want to learn how we can use a very simple method, which is a matrix method, to solve the linear simultaneous equations in 3 variables. All right. So if you have been looking for this video, please, here you go. Here you have it. Utilize it, share it with your friends, subscribe, and give us some comments. Okay, so what is it that we need to know? Matrix method. Matrix method demands the following. All right, for us to apply this method, we need the following. One, we need to know how to compute determinant. Of 3 by 3 matrix, number one. Number two, we need to know how to compute the inverse. The inverse of a 3 by 3 matrix. All right, this is what we need. So for you to find this video very helpful, you need to have that background. Now, there is something again that we need to note. Take note that if you have got matrix A, all right, its determinant is denoted by determinant of, there are a lot of notations like this, determinant of A, or we can use this, all right? Meaning that it's inverse. So A inverse, the inverse of A is this. All right, that is the inverse of A. Now, how do we find the inverse of A? The formula for the inverse of A is equal to 1 divided by the determinant of A. If you want, you can write this times the adjoint of A. This is very important. It's a thing that you need to note. Number two, you need to know that when you multiply A or A inverse by A, the answer always be identity matrix. All right? Now, since we are talking about a 3 by 3 matrix, the identity matrix for a 3 by 3 matrix is 1 0 0 0 1 0 0 0 1. So this is the identity matrix for a 3 by 3 matrix. Take note, when you multiply a matrix by its inverse, you always get the identity matrix. So this is the information that we need. This is the prerequisite that we need for us to be able to solve these equations. All right. With that in mind, please let me take you through. Please, let's enjoy this presentation. Let me take you through. All right, with an example. Okay, so the best is pause the video, try to attempt this question. What is the question? Solve the following systems of equations by matrix method. That is our question. All right, now let's see the actual equations. So the equations are as follows: x plus 2y plus 2z is equal to 3. And the next one is 2x plus y plus 3z is equal to -1. The third one is 3x plus 2y plus z is equal to 7. All right, so let's move on now. So this is our question. This is our question. So allow me to demarcate like that so that I write our answer. Okay, so the first thing that we need to do is to isolate the coefficients. So for this one, we have got the coefficient of 1. So we have got 1. Down there, I've got 2. And you have got 3. For the second part, or the second variable, which is y, the first coefficient is 2, 1, 2, 2, 3, 1. So when you multiply this matrix by the matrix for the variables, we should be able to get this matrix at the end, which is 3, -1, and 7. Okay, I hope that is okay. So I'll say let A be equal to this matrix that we have created, which is 1, 2, 3, 2, 1, 2, 2, 3, 1. All right. So the first thing that we need to do, as you have seen there, is to find the determinant here. We need to find the determinant first, right? How do we do that? Okay, so we are going to say determinant of A, or I can do this. This means determinant. All right, so we are going to deal with the first column. Can use the first column. So the signs are plus, minus, and plus. So for the first number, which is 1, there will be 1. Then you eliminate the first column and the first row, sorry, and the first column. So I've got 1, 3, 2, 1. All right, I hope that it is okay. Then we go to the next one, which is -2. -2. Here it is positive, but the negative is coming from this part. So once you eliminate this and this, you have got 2, 3, 3, 1. Then the last one is +2. what we have, we have, if this is removed and this one, we have got 2, 1 and 3, 2. So from here now, we find the determinant of each. So determinant of A is equal to 1. So 1 by 1 is 1 minus 6. So we get -5 here, minus 2. This is 2 by 1 is 2, minus 9 is -7, plus 2. 2 by 2 is 4, minus 3, you get 1. All right? And once you add this, here it's going to be -5 plus 14 plus 2, and the answer is 11. So that is our determinant. All right. From here now, we have the determinant. We need to find, we need the adjoint. All right. To do that, we must find what we call the matrix of cofactors. The matrix of cofactors. So how do we get that? To get the matrix of cofactors, we are going to use this matrix A. All right? This matrix A here, which is this matrix here. So you're going to create more determinants inside that matrix. So for this one, if we eliminate this and that, you remain with 1, 3, 2, 1. Right? Then you move to the next number, which is this. If I eliminate this and this, you remain with 2, 3, 2, 3, 3, 1. Then if you go to the last one here, you remain with 2, 1 and 3, 2. Of course, we are going to get their respective determinants. I'm done with the first row. You go to the next second row, which is this one. All right. So once I'm at point 2, you eliminate this column. What are we remaining with? 2, 2, 2, 1. All right. Then you change your attention. You come here. You're at A. You're at 1. Sorry. So you're going to have 1, 2, 1, 2, 3, 1. Going to have 1, 2, 3, 1. Then we move. We go to the last one here. So you're going to have 1, 2, 3, 2. Okay. Let me just zoom out. All right. So you are done there. You come to the last column. While there is 3 here, you do that. You eliminate that. I've got 2, 2, 2, 2, 1, 3. Then the next one is this where there's 2. I've got 1, 2, 2, 3. Then finally, the last one is this. I've got 1, 1, 1, 2, sorry, and 2, 1. So this is one matrix. The aim is we need to find the matrix of the cofactors. When we are done calculating, we need to put this plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, let's see how we're going to do it. Okay, so this is what we have now. Okay, so this implies that for the first one here, we will have 1 minus 6, we have -5. 2 minus 9, you have got -7. 4 minus 3, you have got 1. For the second one here, it will be 2 minus 4, -2. 1 minus 6, -5. All right, you have a -5. Then 2 minus 6, -4. Then here, the last one, it is 6 minus 2 is 4. Then 3 minus 4 is -1. Then 1 minus 4 is -3. This is what we have. All right, so once we are done, like I said, we need to slot in these signs. Meaning that for the first row here, we need to put plus, minus, and plus, all right? What that means is that 5 should be allocated a positive sign. All right, and since it's negative, so it will be negative. This should be allocated a negative sign, so it will be positive. This should be positive, so it will remain positive. This should be negative, so negative by negative, it will be positive 2. And this now becomes -5, it will be the same. This becomes 4. Then this is positive 4 because the last one there is positive. This should be positive 1, and that is -3. Okay. So this that we have is the one that we are calling the matrix of cofactors. Take note. It is a matrix of cofactors. So the matrix of cofactors. So to find now the adjoint, of A, we must find the transpose of the matrix of cofactors. So the transpose of the matrix of cofactors will be -5, 7, and 1, -2, 5, and 4, 4, 1, and -3. So this is our adjoint. All right. Now, what we are going to do now is we are going to say, what is our inverse? We've said the inverse is 1 over determinant of A times adjoint. Okay, this implies that the inverse will be equal to 1 over, if you remember our inverse, our determinant is 11, but our adjoint is -5, 7, 1, -2, 5, 4, 4, 1, -3. This is our inverse for matrix A. But now we proceed and solve. So how do we solve? You're going to multiply both sides of the equation by the inverse. Both sides of the equation by the inverse. If you remember, we had isolated from the first part, we had isolated this matrix. We had 1, 2, 3, 2, 1, and 2. 2, I think there was 3, 1. Then we had X, Y, and Z. This was equal to 3, -1, and 7. So what we need to do is to multiply both sides of the equation, that is the left-hand side and the right-hand side, by our inverse. Okay, so our inverse now is the one that we already have there. So what are we going to say? So we're going to rewrite now our inverse, which is the 1 over 11, open the bracket, negative 5. This is our inverse here. Negative 5, 7, 1, negative 2, 5, 4, 4, 1, negative 3. So, but on the left-hand side, we have these matrices. We have 1, 2, 3, 2, 1, 2, 2, 3, 1. And there's X, Y, and Z. All right. This is equal to, again, so this inverse will be introduced on the right-hand side. So I've got 1 over 11, negative 5, 7, 1, negative 2, 5, 4, 4, 1, negative 3. Okay. Then there is also 3, negative 1, 7. Okay. Good. But remember we said, when you multiply an inverse by a matrix, you get an identity, meaning that when you multiply this part, because there's an inverse and the matrix itself, will get an identity. So the identity for a 3 by 3 matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. This, if you want, you can multiply, you arrive at that, but you just waste time. Right. So this is what we are going to get. Then we'll have 1 over 11. So here you can multiply. You can multiply negative 15, negative 5 plus by 3, sorry, you get negative 15. Negative 2 by 1, you have positive 2. Then 4 by 7, you have got positive 28. Okay, I've got positive 28. Okay. It's always important to take note of the signs. All right, so that you don't make any mistake. Okay, so I'm just trying to verify the okay, so take note here. When you look at this, this is positive. All right. So this must be positive. You need to take note. So that must be positive. And this must be positive. Okay, meaning that this must be positive and this must be positive. All right, so meaning that here it's going to change. It's going to be positive 2 by negative 1, negative 2 plus 28. Okay, then 7 by 3 is 21 plus plus 5. So we are going to say 5 by 1. Okay, so I'm just trying to make sure that the signs are correct. Okay, I have to make sure that good. So we're leaving out something. Again, you can check that this is negative, so this is supposed to be negative, and that must be negative. It's very easy to make those mistakes. Right, so this must be negative, this must be negative. Okay, so -5 by -1, we get +5. All right, then 1 by 7, we get +7. Good. Then 1 by 3, we get 3. Then 4 by -1, we get -4. Minus 21 is what we have. Good. Now, again, when you multiply, for example, a matrix by an identity, the answer will always be the matrix. All right. So in this case, when you multiply this with that, the answer will be this matrix, which is the X, Y, and Z. This was 1/11. So when you add -15 minus 2 plus 28, you're going to get 11. 21 plus 5 plus 7, you're going to get 33. Then 3 minus 4 minus 21, you get -22. Okay, so this implies that X, Y, and Z as a matrix will be equal to, when you multiply 1/11 by 11, you get 1. Then 1/11 by 33, you get 3. 1/11 by 22, you get -22. What does it mean? Therefore, X is 1, Y is equal to 3, and Z is equal to -2. Those are the solutions for those simultaneous equations. Thank you so much. Subscribe and share. Thank you. See you in the next presentation. Thank you.